Good morning, good afternoon. Welcome to Graph+AI Summit. My name is Ivan Portilla. I'm an AI leader at IBM. And we also have today one of my students at the University of Colorado, Claire McCullough. Today we'll be speaking about graph data science, specifically with TigerGraph Graph algorithms. Here's our contact information, and we're also going to publish these slides in some of the Jupyter notebooks to a GitHub repository listed on this note. Before I start, I would like to tell you a story how I get started with knowledge graph or graph databases. A few years ago, I was working on a project for one of our largest customers in the travel and hospitality industry in IBM, and we created this cognitive concierge robot. And this robot uses some of the IBM Watson APIs, but it also uses graph databases to answer the questions guests will ask to the cognitive concierge at the hotel. You can watch the whole story there, and we have also a post on Medium. Our presentation today is very simple. We're just going to talk about three things. We're going to talk about graph databases, what graph data science is, and do a quick demonstration using TigerGraph Graph Data Science library. So let's begin. Before I go into the different agenda items, I want to highlight that we have two major technologies demonstrated today. We're using TigerGraph Graph Data Science library, and we're also using IBM Watson Studio. In IBM Watson Studio, you're going to be able to build, run, and manage AI models. And one of the AIs that we're going to be using is the Watson Natural Language Understanding. So these two APIs will be used in conjunction with TigerGraph Graph Data Science library. Let's begin with graph databases. What is a graph, you may ask? A graph is simply a network of real-world entities, and this can be anything. It could be objects, items, or even concepts, and their relationship between them. Important to remember that a graph database stores the data with its relationships. But why do we want to use graphs? Recently, I was working with a customer, and this customer was worried about these cybersecurity attacks. So one of the first things that we did was to map out the whole network topology on a graph database. And in this network, we routed the different routers, ports, and applications, and it will help us prevent these cybersecurity attacks. Something more pertaining to what you do every day, we're using graph databases to do contact tracing, particularly with the COVID-19 pandemic. So suppose that you go to a conference, you go to a meeting, you've been on an airplane, you took a subway, you met with some relatives. Through a graph database, we can do who seated with you in the bus that is also exposed to this COVID, and we can alert them that they need to be tested or make sure they have vaccinated. When we talk about graphs, we're talking about two major components. We talk about nodes and relationships. The nodes are the main data elements in a graph. They're also known as vertex. And the relationship or edge is the link between these two nodes. And it has two attributes. It has a direction, it has a type. Notice that we are allowed to have nodes without relationships, but no relationships without nodes. Now let's talk about graph data science. Graph data science is a subset of data science, and we're using connected data. And particularly, we're looking at those relationships in the data beyond the data points. And as data science is a combination of different technologies. So we're using graph data structures with graph analytics, with graph modeling algorithms and visualizations. In a nutshell, data scientists use their relationships and your data to answer business questions. Now, when we look at TigerGraph in database graph data science library, we're looking at the best of the kind for best performance scalable libraries. Each of these elements is a well-defined GSQL query, and is implemented either as a standard graph or as a machine learning algorithm. Each algorithm is ready to be installed or used as a standalone or as a component of a larger analytical application. GDSDL delivers high performance and scalable graph analytics. We see in this graph that we have 50 plus algorithms and more are coming. So let's take a look at some of the families of graph data science algorithms. So if we go from the top, one of the most commonly used is centrality. We usually use centrality when you do a Google search. It determines the importance of some nodes in your network. Then we want to look at how the graph is partitioned with community or clustering. Then we can do a classification. This is important in machine learning, and we assign labels to a node based on some conditions. And most recent one that is being provided to us is the node embeddings. With node embeddings, we can do vector representations of the properties of these nodes in a graph for machine learning. We also have path finding, the optimal path between two nodes for routing, availability, and quality. And lastly, we also have similarity. What people are buying, so do similarity collaborative filtering, and it evaluates how two individual nodes are alike. If we look at those family of algorithms and look at some practical business use cases, we have these examples. For instance, if you're looking for the influencers, like in social media or in your organization, you're looking for the best actors in your healthcare provider, you'll use centrality. Every time you make a phone call through the telecommunication network, it routes your call through pathfinding. Or if you are looking at business recommendations, like you're buying a book or watching a movie on Netflix, you're using the node similarity algorithm. So these are some of the examples that we have applying graph data science in a TigerGraph library. Now for the demonstration, I'm going to introduce the business case, and then I'm going to switch it over to my colleague, Claire, that she's going to take us through some examples. So basically what we have here is a collection of blog posts that have been analyzed, and we're going to use Jupyter Notebook to create a TigerGraph database, and we're going to visualize the results. And basically what we're doing is we create an ontology, a knowledge graph with some entities associated with those blog posts. And then we're going to look for common themes using centrality, PageRank algorithm. And then we're going to look for partitions or clusters on those articles using community lobbying. So Claire, why don't you take us through this demonstration?
Thanks, Ivan, for that introduction. Welcome to Watson Studio. This is a great platform for collaborating among data scientists and other people who are on projects. All of your data is stored in the cloud, and all of your notebooks are stored in the cloud. It also integrates with Git, which is a great option. You'll see here that I have my projects here. We will go ahead and look at the Graph+AI project, which I have loaded here already. We have 4 main tabs up at the top: Overview, Assets, Jobs, and Manage. We'll take a look at the first 2. I'm already on the Overview tab. This shows a brief overview of your assets and your resource usage. Watson Studio has 2 primary plans. The first one is free, and you have a certain number of capacity unit hours per month. The second plan is paid, and it has a more standard number of capacity unit hours per month. All right, now we will look at our assets. In Watson Studio, there are 2 primary kinds of data assets. So, of assets. The first one are data assets. You can see here we have 2 CSV files, which we will look at momentarily. We also have code assets. In our case, these are Python notebooks, but we will start by looking at our CSV files. For this demonstration, we'll start by looking at our blog's CSV file, which I already have loaded. This is a pretty basic CSV that has our blog ID, the name of the blog, the URL for the blog, and the date that the blog was published. Next, we sent this into an instance of Watson Natural Language Understanding, which uses an ontology to assign categories and scores for each of those categories. The asset we will look at next is actually the output of one of the notebooks we will look at. So this CSV file is after our original CSV about blogs has been processed by Watson Natural Language Understanding. We have the same blog links. This category was assigned by Watson Natural Language Understanding and the ontology, and we have the score. A higher score here is going to make a difference in our TigerGraph. All right, so next we will look at our notebook assets. We're going to take a look at two of them. The first one is our code for accessing Watson Natural Language Understanding on the IBM cloud. We started by installing and loading our IBM Watson libraries. We then loaded those blog data assets from Watson Studio on the cloud into our notebook so we can access them. We loaded them as pandas data frames. You can see the first part of the data frame here. Then we initiated our Watson Natural Language instance so that we can submit our data frame to Watson. After we submit it to Watson, Watson NLU sent us this JSON, which has the blog, the category, and the score, which we then parsed into a data frame. All right, the next notebook is where it gets exciting. We installed TigerGraph libraries, and this is going to prepare the data for the demo that Yvonne is going to do with TigerGraph. So we loaded our TigerGraph server, we connected our Python instance to our TigerGraph instance. We imported our blog data asset once again as a data frame. You can see we've got our original data frame here and our scored data frame here. Then we do some analysis or some queries with our TigerGraph library. These are some examples, but Yvonne will show the TigerGraph side momentarily. We're doing some sample queries, and our two main algorithms that we are using with TigerGraph here in this demonstration are PageRank and centrality. I won't go into the rest of this query here, but this is how we are querying so we can use those algorithms. And next, Yvonne will demonstrate TigerGraph. Thank you.
Thank you, Claire. So basically what we saw today, we use Graph Data Science, graph databases, and we use some of the algorithms to look at the ontology of the data, and then looking at some properties on ontology algorithms that we have created with Watson Natural Language Understanding. We can classify those blog posts with different entities. And then we're able to visualize the ontology of the whole cluster of articles. And then we use centrality, PageRank, to measure the connectivity of those nodes. And we determine which were the important nodes in my graph, my knowledge graph. And we also use community detection using Louvain, and we use TigerGraph Graph Data Science library to determine the clusters of important articles in my publication. So now, if you want to try some of these Graph Data Science libraries to get you started, you can use TigerGraph either on the cloud sandbox or install it local as a Docker container, or use the enterprise edition. So here's a link, and then you can install the open source library, JDSCL, from GitHub, from TigerGraph GitHub repository. And I encourage you to look at some of the tutorials available to learn more about graph data science. Thank you very much. This is my contact information. I also strongly encourage you to read this O'Reilly book about using analytics and machine learning with TigerGraph. Thank you, everyone.